Bismillahirrahmanirrahim. Today our topic is turning effects of forces.
The moment of a force. Moment, the quantity that tells us the turning effect of a force about a pivot. The moment of force is bigger if 1. The force is bigger. 2. It acts further from the pivot. 3. It acts at 90 degrees to the object it acts on. Beam, a long, rigid object that is pivoted at a point. If the beam is to be balanced, the moments of the two forces must cancel each other out. Equilibrium is when a beam is balanced. If an object is equilibrium, 1. The forces on it must be balanced. 2. The turning effects of the forces on it must also be balanced. Calculating moments. Moment of a force equals force x perpendicular distance from pivot to force m equals F *d. The unit of moment of force equals Nm, Newton meter. Balancing moments. Total clockwise moment equals total anti-clockwise moment. Example worked question, identify the clockwise and anti-clockwise forces. Two forces act clockwise, 20 n at a distance of 0.5 m, and 10 n at 1.5 m, one force acts anti-clockwise, the force F at 0.5 m from pivot.
This is the example and task at home. This is the solution, but I'm not going to explain this one. Basically very simple. I'm going to give you some hint. Clockwise moment is equal to anti-clockwise moment, okay, in magnitude of both two cases. So in clockwise moment, the 20 Newton at a distance 0.5 meter, so multiply to each other, we will give us the result 10 and plus 10 Newton multiplied by 1.5, so the both are the clockwise moments, and by multiplying these two terms we will get 15 Newton meter. These all are clockwise moment, and just adding these two terms we will get the 25 Newton meter on the left side. And the second anti-clockwise moment is force F multiplying by 0.5, and just by calculating these values we will get the result. Force is equal to 25 Newton meter divided by 0.5 meter, and the final answer will be 50 Newton. Okay.
Center of mass. Center of mass, the point at which the mass of an object can be considered to be concentrated.
The center of mass, basically this is the center of mass, and the whole mass act on this place. So if we give some force here, it will be stabled, okay, but the point should be center of mass. Summary.
The moment of a force is a measure of its turning effect when a system is in equilibrium. The resultant force is 0 and the resultant turning effect is 0. For an object to be stable, its center of mass must be low down and it must have a large base. Moment of a force equals force x perpendicular distance from pivot to force. Question 1. What quantity is a measure of the turning effect of a force? Question 2. What two conditions must be met if an object is to be in equilibrium?